Hello and a very good evening to one and all present here, and welcome to the session on classification of numbers, LCM, HCF and factorials. So these are very tiny topics, so I thought that I would do them together. Okay, so and remember, we are not going to go very deep into each topic, we're just going to look at it from the exam point of view. Okay, because going too deep into classification of numbers or whatever would definitely take too much of time for us, unnecessary time in doing things that are not that important. Okay, so we'll just look at the previous questions that have come in the paper, and accordingly I have taken the concepts and also the questions that are here, right? So yeah, now let's go deeper into the topic. First of all, classification of numbers. A quick rush through this topic because it's very short. So classification of numbers, I can say that any number that you utter can be put in the category of complex numbers. And remember that complex numbers are in the format a plus ib. Okay, it has got the imaginary part as well. Now, if the value of b turns out to be 0, then you lose the imaginary part and you are left only with a real number. And then if b is not equal to 0, then the number becomes an imaginary number itself. Okay, but note that as far as aptitude is considered, okay, we don't need to deal with imaginary numbers and all, so you can just forget about this part. After that, real numbers can then be segregated as rational numbers and irrational numbers. So rational numbers and irrational numbers, most of us know, any number that can be written in p by q format, where p and q both are integral values. Okay, and q is not equal to 0. Why q is not equal to 0? If the denominator is 0, the fraction becomes undefined. So the denominator should never be 0. So here p and q both have to be integral values. And any number that cannot be represented in such a way is going to be an irrational number. So at this particular point, okay, there may be numbers from these important concepts. First of all, rational and irrational. Okay, we need to try to figure out what kind of numbers are rational, what kind of numbers are irrational. So let us just have a quick go through. If I talk about the number 4, the number 4 can be written as 8 by 2 or 4 by 1. So this is going to be a rational number. Now I'm talking about 2.1. 2.1 is nothing but 21 by 10. Okay, so you can write it as a rational number. Now if you see now, if there are finite number of decimals, you can already divide it by 10 to the power that and it will give you a rational number. Okay, so all finite decimal numbers are going to be rational. Okay, now talking about square roots. When I have square root of say for example 3, okay, where this is either a prime number or this is not going to be a perfect square, then this number will become an irrational number. And if I'm going to have a square root of a proper square, then that turns out to be a rational number. Other than this, okay, we have spoken about finite decimals. Now talking about infinite decimals. That means they are non-terminating decimals. Okay, non-terminating decimals can be of two types: recurring decimals and non-recurring decimals. Now remember that recurring, okay, is like 3.1111, where 1 keeps on repeating up to infinity, and non-recurring is like 3.12478, and you don't know what are the terms that are coming beyond. Okay, but it goes on up to infinity. Okay, like the value of pi and all. Understood? Now, out of these, when you have non-terminating recurring numbers, they are all going to be rational, and non-terminating non-recurring numbers are going to be irrational. Right? Now, after this, the major question that will pop up is how do you convert a non-terminating recurring decimal into a p by q format or into a rational format? Okay, so let us take a small example here. X is equal to 3.111 as I have taken in the question. Now, you need to convert this into a rational number, which is going to be integer by integer. That means you have to lose the decimals, right? So, if I have two numbers with the same decimal part and I subtract them, the decimal value vanishes. So I have to get now two numbers which have the same decimal part. Okay, so for that what I do is I check how many distinct digits are here after the decimals which are repeating. How many distinct digits are repeating after the decimals? Only one, correct? Only one. So what I do is I try to bring it before the decimal point. So to bring it before the decimal point, I have to multiply it with a 10. So now I land up with 31.111 up to infinity. Now these two numbers have the same decimal part. So subtract them, 10x minus x is going to be 9x, okay, and 31 minus 3 is going to be your 28. So x lands up with 28 divided by 9. So this is the answer. You put in your calculator for this value, you will be landing up with a recurring decimal, which is going to be 3.111. Okay, so this is how you convert a non-terminating recurring number into a rational form. Okay, this one you will not be able to convert because it is a rational number. Understood? Now, next, after rational numbers, okay, rational numbers can then be further divided into integral values and fractions. So fractions, you have mixed fractions, you have improper fractions, proper fractions, everything. And then integral numbers, you have negative numbers and you have non-negative numbers. Okay, now I haven't separated as negative and positive because then 0 would lose its place. So negative and non-negative here. So non-negative numbers can then be further divided into your prime numbers, composite numbers, whole numbers, natural numbers, and so on. Okay, the next two important categories will be your prime numbers. Okay, your prime numbers will be there. Okay, so first of all, on the chat box, please do tell me what is a prime number. On the chat box, please do tell me what is a prime number. What is a prime number? See, most of us believe that a prime number is a number which is divisible by 1 in itself. Okay, if I look at 1 is divisible by 1, it's also divisible by itself. So is it a prime number? Is 1 a prime number? No, correct. So we will slightly change the definition. We will not change the definition, we will slightly modify the definition so that we can properly differentiate between prime and composite numbers. So prime numbers are the numbers which have exactly two factors. They have two distinct factors. And these two distinct factors are 1 and itself. And any number that has more than two distinct factors, then that number is going to be a composite number. Okay. Now, let us just gist down for our familiarity with the prime numbers. Let us just gist down all the prime numbers from 1 to 100. Okay. Look at this. We have 2, 3 and so on. Okay. Now, remember that any prime number that you take will be in the format 6k plus or minus 1 after 2 and 3. Okay, and 2 is the only prime number that is going to be even. Okay, so first write down 2 and 3. Then after that, instead of checking is 4 a prime number, 5 a prime number, 6 a prime number, 7 a prime number and all. So you start checking for prime numbers in the format a multiple of 6 minus 1 or multiple of 6 plus 1. So first multiple of 6, okay, is going to be 6. 6 minus 1, 6 plus 1. Next 12. 12 minus 1, 12 plus 1. But you will not always get these numbers as prime, my dear. So you are just checking. So double check before you write down the number. Okay. Then you have next is 18. 18 minus 1, 18 plus 1. 24. 24 minus 1 is prime, but 24 plus 1, 25 is not a prime number. So I'll have to omit that. 30 minus 1, 30 plus 1. 36 minus 1, 35 is not a prime number, but 36 plus 1, 37 is going to be a prime number. So that way you can go in numbers which are in the format a multiple of 6 minus 1 or plus 1 and check whether they are prime or not. Double check it and then you write down the numbers. Okay. Now the digital sum. What is the meaning of digital sum? Whenever you get questions on digital sum is nothing but whatever digits are involved. Say for example, I have 2, 4, 1. Okay. Digital sum will come out to be a single digit number. So 2 plus 4 is going to be here 6. 6 plus 1 is 7. Now if I have 974. Okay, then 9 plus 7 is going to be your 16, 16 plus 4 is going to be 20. Now, you can't have a digital sum to be a two-digit number. Whatever digits here you get, 2 plus 0 also added, 2 is going to be the digital sum there. Okay, so the digital sum of any prime number cannot be what? Okay, let us have a look. First, 2, the digital sum is 2. So, 2 can be. 3, digital sum is 3, that also can be. Now, 5, digital sum is 5, that also can be. Okay. Now digital sum here for 7 is 7, that is also possible. So 11 again digital sum is 1 plus 1 which is going to be 2, which I have already cancelled out. 3 plus 1 is 4, so that is also possible. 17 is 7 plus 1, 8. That's also possible. 9 plus 1 is 10. So 1 plus 0 is going to be 1. That is also possible. 2 plus 3 is 5. I think I have that cancelled out. And then 2 plus 9 is 11. 1 plus 1 is going to be 2. 3 plus 1 is 4. Then 10. And 3 plus 7 is 10. And then 1 plus 0 is again a 1. 4 plus 1 is 5. 4 plus 3 is 7. 4 plus 7 is going to be 11. So 1 plus 1 is going to be 2. So this is 8. This is going to be 5. This is going to be 7. This is going to be 13. So 3 plus 1 is 4. Okay. So you get the same thing. Okay. So you can say that the digital sum of any prime number can never ever be 6. It can never ever be 9. Okay. Right. So with this, I think classification of numbers is done, my dear. Okay. So we normal basic problems you might have been doing a lot. So we'll just look into two different types of problems. Okay. And then we'll go to the next topic. So here, I want you to do this problem. I'll give you a total of 1.5 minutes. Okay. Not it's worth only 1 minute, my dear. Please take this number. Is 3 to the power 193 plus 5 a prime number or not? And please put your answer on the chat box. Okay, so let's go with the discussion of this problem, my dear. First of all, have a look at this. 3 to the power 193. This 3 is going to be an odd number. Odd number raised to the power n. Like look at 3 power 1, 3 power 2, 3 power 3. Okay, 3 power 1 is going to be 3, 3 square is going to be your 9, 3 cube is going to be 27 and so on. So odd number to the power anything is always going to give you an odd number. So you take 3 to the power 193, which is going to be an odd number, plus 5 is also an odd number. Okay, so odd plus odd, what kind of a number will you get? You will be getting an even number. Okay, and even number is nothing but a multiple of 2. Okay, now, yes, I know that, okay, even number could be a prime number. Okay, but the only even number that is, the only even number that is prime is going to be 2. But sum of this plus this cannot be 2. It definitely has to be greater than 2. Understand? So, the even number that's coming up, okay, has to be greater than 2. So it is never ever going to be a prime number because 2 is the only prime number which is even. Okay, so now you're getting an even number which is greater than 2 means definitely this number is not going to be a prime number. Okay, this number is going to be definitely divisible by 2. Clear? Right. Now let's move on to this one. Okay, just a simple conversion of a decimal value, which is a non-terminating decimal, recurring decimal into your PYQ fraction. Please do this 1 minute for this, and then we'll go on with the discussion. Okay, so enough of time for this as well. Okay, now when you have a look at this number, okay, the previous example that I gave you was for a number for which after the decimal the terms are repeating. So first convert this into such a number. Let x be 2.01333 up to infinity. Okay, but now here there are two digits after the decimals which are not repeating. So first transfer them forward. So multiply this by 100, you'll end up with 201.333 up to infinity. Now, these two numbers, if you compare, the decimal value is not going to be the same. So now you need another number which has the same decimal. So what I do is now, this format has terms which are repeating after the decimal. Check how many distinct digits are repeating after the decimals, only one. So bring it forward now. So you have to multiply it again with a 10. So now you get 100x into 10 is nothing but 1000x is equal to here 2013.333 up to infinity. Now you directly go and do the subtraction, because if you look at these two numbers, okay, the decimal part of these two numbers is going to be the same. So without any worries, we can just go and cancel those numbers. So if you look, 1000 minus 100 is going to be nothing but 900 is equal to, here I'll end up with 2013 minus your 201, correct? And that number is nothing but 1812. So you'll end up with x is equal to 1812 divided by 900. This is the fraction or the rational format of your number 2.01333 up to infinity. Okay, so yeah, so with this I think not very difficult type of questions come from the classification part. Okay, so just to brush through the concept and to make you like do a few problems so that you understand it properly. Okay, we had taken up this. Okay, now let's move ahead to the next topic here. See, basically we are now going to target LCM and HCF. Okay, now first of all, let us define what is LCM of a number. LCM of a number is nothing but the least common multiple. So least common multiple, what I can do is, least common multiple is nothing but the product of the, if I'm taking two numbers or three numbers, whatever, the product of their prime factors, the product of their prime factors, but each of them raised to the highest power available, each of them raised to the highest power available. Okay, and similarly for HCF also. Okay, it's going to be much more simple. I'm just going to take HCF as a product of their prime factors, each of them raised to the lowest power available. Okay, highest power available, lowest power available. Understood. Now let us just discuss a small concept here, how to figure out the LCM and HCF using this particular concept. So let us take a number. We already know how to prime factorize numbers. So let a number be here 2 square into 5 power 1. Okay, and let another number be here 3 to the power 4 into 7 to the power 1 into 5 to the power 3. Now if I want to figure out what's going to be the LCM of these two numbers, first of all, product of the prime factors. This number is properly prime factorized, which means 2 and 5 are its only prime factors, and this number, the prime factors are 3, 7 and 5. So the prime factors involved here are 2, 3, 5 and 7. Product of these prime factors, each of them raised to the highest power available. So can you tell me what is the highest power of 2 that's available from these two numbers? What is the highest power of 2 that's available? 2 is available, correct? Now what is the highest power of 3 that's available? What is the highest power of 3 that's available from both the numbers? I know that 4, right? Here I have 3 power 4. The highest power of 5 that's available from both the numbers? 5 power 1 here, 5 cube here. What is the highest power of 5 that's available? 3. And what's the highest power of 7 that's available? Obviously 1. So this becomes the LCM. And talking about the HCF of these numbers, okay? Again, product of the prime factors 2, 3, 5 and 7. But right now each of them raised to the lowest power available. What is the lowest power of 2 that's available? Remember, here I have 2 square, but here I have 2 power 0. So lowest power is 0. Okay. And here lowest power of 3. Here I have 3 power 4 and this side I have 3 power 0. So lowest power of 3 is also 0. Now lowest power of 5. I have here 5 power 1, 5 cube. Here lowest power is 1. And for 7, here I have 7 power 1, here I have 7 power 0. So lowest power is going to be 0. So HCF of these numbers remains as only 5. Understood? So you can easily figure out the LCM and HCF of numbers using this particular method. Okay. Now, apart from this, okay, LCM and HCF, you will be asked simple basic questions. Okay, which is the least number? Which is the least number that is divisible by 2 and 4 and 5? Which is the least number divisible by 4 and 5? Which is the least number divisible by 4 and 5? Please put it on the chat box. The least number that is divisible by 4 and 5. You will take it as 20, nothing but the LCM of 4 and 5. So when you are asked to figure out what is the least number divisible by x and y, you just have to go with the LCM of x comma y. Okay, if you ask for the second least number, then it will be nothing but LCM of x comma y into 2 and so on. So the least numbers, okay, nth least number will be nothing but LCM into your n value. Okay, least number will be nothing but LCM into 1. The second least number will be LCM into 2 and then so on. Okay, now if you want to figure out which is the least number that when divided by 4 and 5 leaves a remainder of 1, leaves a remainder of 1. Which is the least number that when divided by 4 and 5 leaves a remainder of 1? Now most of you will tell me that the answer is 21. Okay, no, the least number that when divided by 4 and 5 leaves the remainder of 1 is going to be 1. Look at this number, 1 by 4, the remainder is going to be 1, and 1 by 5, the remainder is going to be again 1. So the first number of its kind is 1. Okay, from here on, what you will do is, the remainder is 1, right? So in generic, if the remainder was not 1, if the remainder was simply given to you as A, okay, if the remainder was simply given to you as A, then what you have done? The first number of its kind would have been A. After that, what you have done is take the LCM of x comma y. Okay, the next number, okay, here would be 21. The LCM of x comma y into n plus a. So here n will start ranging from 0, 1 and so on. So the least number which when divided by 4 and 5 that leaves a remainder of 1 would be nothing but LCM of 4 comma 5 20 into 0 plus 1. Okay, next will be 20 into 1 plus 1, 21. 20 into 2, 40 plus 1, 20 into 3, 60 plus 1 and then so on. The numbers will go on like this. Okay. Now remember that remainders now can not only be positive, they can also be negative. Like say for example, I can say when I divide a number 8 by 3, the remainder is 2, right? So this is the positive remainder. We tell that this is a positive remainder. Why? Because 8 can be represented as 3 into a multiple of 3, which is nothing but 3 into 2 plus 2. So from a multiple of 3, there is 2 in extra. So that surplus value is taken up as the positive remainder. I can also say that the same number 8 can be represented as 3 into 3 minus your 1. 9 minus 1. So from a multiple of 3, I can write it as minus 1, which means there's going to be a deficit of minus 1. So at a particular moment, there will be two remainders, positive remainder and a negative remainder. Positive remainder is easy to figure out, okay? But once you have got the positive remainder, the negative remainder is very easy. Here, 8 by 3, the remainder was 2. So the negative remainder will be nothing but 2 minus 3, which is going to be a minus 1 there. Okay, you can directly get it this way. So in case negative remainders are also there, then this sign will only change. Nothing else is going to matter much. Getting it? So this is how we deal with numbers, okay? But for numbers wherein you don't have the positive difference to be same, you don't have the negative difference also to be the same. Okay, like say for example, when a number is divided by 3, the remainder is 1. And when the number is divided by 5, okay, the remainder is going to be 2. Now, if you look, the positive remainder here is going to be 1 and 2. Okay, it's going to be 1 and 2. Okay, they are not the same. The negative remainder in this case, this is 1 minus 3 minus 2 here, and 2 minus 5 is minus 3. Negative remainder is also not the same. So for these kinds of problems, there's no other way than to first you discuss first of all using equations. So the number in the format 3x plus 1 is the same number which is also when divided by 5, it leaves a remainder of 2. Right, so now we have got it. So I can say 3x is equal to, first you figure out. So the number will be in what format? Okay, LCM of 3 comma 5 into n plus the first number of its kind. The first number of its kind. That I have to figure out using this LCM method. So first, let me go here. Okay, 3x is equal to 5y plus 1. Now I can say x is equal to 5y plus 1 divided by 3. So I can also represent the same thing as 3y plus 2y plus 1 divided by 3. Correct. Now 3y is already divisible by 3. So 2y plus 1 should be divisible by 3 here. Understood? So start checking out by trial and error. So if I put y is equal to 0, the number is not divisible by 3. Okay. Now if I put y is equal to 1, 2 into 1, 2 plus 1, 3 is divisible by 3. So the minimum value here of y should be 1. So substitute 5 into 1 plus 1 is going to be nothing but 6. So the first number of its kind is going to be nothing but, okay, wait here. The minimum value here, you're getting 3x is equal to 5y plus 2, correct? 3x plus 1 and 3y plus 2. Yes, so when this comes this side, you'll end up with plus 1. So 3x is equal to 5y and yeah, 2y plus 1. Okay, so you will try to figure out the first number of its kind here, which is coming as 6. Okay, so let's check. If I divide a number 6 by 3, when I divide a number by 3, am I getting a remainder of 1? No, somewhere we have done a mistake. So let's just check it out, or whether it is not possible. You take, yes. So if you take a multiple of 3 plus 1, 4, okay, will it ever give you this thing, 5y plus 1? No, it is not going to give you. So a multiple, no. I think you are not going to land up with such a number. That is why this particular thing. Okay, so always remember that whenever you do not have the positive remainders and the negative remainders constant, then you definitely have to go with this particular method. Okay, now in this case, okay, the only thing was there are numbers which are not possible in that case, so you should be ready for those also. Okay, so in that case the number will be 0. You will land up with a particular value here, okay, but that try to substitute that and also check it. Okay, so you are not getting that, so please put that it is not coming. Understood? Right. So now let us have a small look into a problem where you have to figure out the HCF of numbers. Now look at these particular numbers. Okay. If I want to prime factorize these numbers, prime factorizing of these numbers itself is going to take me around 2 to 3 minutes in the exam hall. Okay. So I'm not going to use that method. For HCF, I can also use another method, which is the difference method. So what I will do is, if I have X, Y, and Z, okay, large numbers, I will arrange them in ascending order and I'll try to figure out the difference between them. Okay, the HCF of these numbers, the HCF of these numbers will be nothing but one of the factors of the least difference among D1 or D2, whichever. Okay, so first of all, let me arrange these numbers here in ascending order. The first number that is going to be here is nothing but 1344, correct? The first number that's going to be here is 1344. Okay, and then after that I have 1408, then I have 1728, okay, and then I have the number 1856. So start getting the consecutive difference between these two numbers. The first number is 1344 and then the next number is 1408. Get the difference between these two numbers. The difference is 64. Now get the difference between these two numbers here. Okay, the numbers here are 1408 and then the next number is nothing but 1728. The difference here is going to be 320. Okay, then go with the next set of consecutive terms, 1728 here minus here 18 and 56, correct? So this difference is going to be 128. Now the least difference here was 64. So I will look out for the factors of 64. 64, what are the factors? 1 into 64, then I have 2 into 32, 3 will not go, then I have 4 into 16, then I have nothing but 8 into 8. So I can stop here. So these are all the factors of 64. Now for the highest factor, I will start looking at the factors of the difference here. Okay, the factors of this 64 here. Let's start with the highest number now. So check if 64 divides all these numbers. Look at 1344 and check whether this is divisible by 64 or not. It'll go exactly 21 times. Okay, and then let's look at 1408. Obviously it should be divisible because the difference here is going to be, I think, a multiple 64. We'll check it out. So 1408, you divide it by 64 and check, you will get exactly 22. Okay, now the next term that you take here is nothing but 1728, right? That one you divide by 64 and check, you will get a remainder of 27. Oh, sorry, you will get a quotient of 27. Okay, finally 1856 you divide it by your 64 and check, you will get a quotient of 29. So all these numbers are divisible by 64. So the HCF of these numbers becomes 64 HCF. Okay, so using this particular method of a difference also, whenever the numbers are large and you have too many numbers, instead of prime factorizing and spending more time, you can go with the difference method to figure out the HCF. So now let's have a little bit of discussion over a few problems here. Okay, so please try this problem. How many pairs of positive integers exist such that the HCF and LCM is going to be 91? The sum of the HCF and LCM is going to be 91. Go ahead. Around 1.5 minutes. Please put your answers on the chat box. Thirty seconds more. Okay, let's now go ahead with this particular problem. See, how many pairs of positive integers exist such that the HCF and LCM of these numbers is going to be 91? Now, let me assume that the HCF of these two numbers, is going to be H. So, if the numbers are X and Y, then I can say that the numbers are going to be in the format H into A and H into B. Now, HCF is going to be H, means A and B, there should be nothing common between them other than 1. That means A and B have to be numbers which are going to be co-prime to each other. Co-prime numbers are numbers which have a HCF of 1, my dear. There's no other factor that's common between them other than 1. Okay. So, how would I take the LCM of the numbers to be? The LCM of these numbers would be nothing but H is common between them. And then now A and B are there. Okay, so A and B are co-prime numbers. And again, when you want to take the LCM of the co-prime numbers, okay, LCM of two co-prime numbers is nothing but the product. So you will take these numbers as it is, H into A into B. This is going to be the LCM of these numbers. Okay. Now let's make use of the concept that they have given here, or the condition that they have given here. HCF plus LCM is equal to 91. So HCF is going to be H plus LCM here is going to be H into AB. Okay, this is going to be 91. So taking out H outside, I'll end up with 1 plus AB is equal to 91. So now I need to factorize this 91, correct? So let me factorize. I can write 91 only as 1 into 91 and also as 7 into 13. I think there's no other way in which I can break up this 91. So first of all, the HCF of two numbers, can it be 1 here? Can the HCF of two numbers be 1 here? Is it possible or not? Possible, right? So if the HCF of two numbers H was equal to 1, okay, then I've got 1 into here. This would be nothing but 91. So 1 plus AB would have been here 91. So in that case, AB would have been 90. And remember that A and B are two co-prime numbers, and product of two co-prime numbers has to give you 90. So how is it possible? 1 into 90 is possible. Then 2 into 45 is also possible. And then 3 into 30 is not possible because then the HCF would become there 3. Then 4 is not divisible. Then 5, yeah. Then I think I can take 5 into 18. That's also possible. And finally, I think 9 into 10. So these are the only ways I can break it up as two numbers which are going to be co-prime to each other. So here I get four different ways. Okay, now with the HCF is equal to 1, I have taken it. Okay, now can the HCF be 91? If the HCF is 91, two numbers, okay, see if the HCF is 91, okay, then the least number would be 91 plus 91, which is definitely going to be greater than 91. The sum itself has to be 91, so 91 is not possible. Okay, this is not possible. So now let's target the HCF to be here 7. Now, if the HCF is going to be 7, okay, 7 into the remaining here, 1 plus AB has to be 13. So AB will have to be nothing but 12, and A and B both have to be two co-prime numbers. So 1 into 12 is possible and 3 into 4 is possible. Okay, so these two are again possible here. Okay, and then going on with, let the HCF of the numbers be 13. If the HCF of the numbers is 13, then remember that 1 plus AB has to be 13 into 7 has to be 7. So AB will be equal to 6. So AB and both have to be co-prime to each other. So how is it possible? 1 into 6 is possible, 2 into 3 is possible. So again, two ways are possible here. Okay, now they've asked you how many positive integers exist, right? So the number of things 1, 2, 3, 4, 5, 6, 7 and 8. Understood? So there were 8 ways that were possible. That's all. Now going on to the next question here. So I would like you to please take this problem and I would give you a maximum of 1 minute for this. The sum of two numbers x comma y is going to be 1050. What is the maximum value of the HCF between x and y? 1 minute for this. And please put your answers on the chat box. Okay, so I think this was enough time for this particular question. See, sum of two numbers x comma y. So sum of two numbers x comma y is 1050. Okay, what is the value of the HCF? So what is the maximum value of the HCF? Now remember that if these numbers are h into a and h into b, where a and b are going to be co-prime to each other, okay, 1050, you can take h common here. H into a plus b is equal to 1050. That means in all ways the HCF has to be a factor of this number. HCF has to be a factor of this number. So let's look at the factors. 1 into 1050. Okay, then I have 2 into 500, and I think this is how much? 25. Okay, then I can go with 3 into here. I'll end up with 3 and then a 5 and then a 0 and so on. But remember that I need the maximum value of the HCF and the maximum value of the HCF. So I'll start choosing the maximum values. Now can I choose 1050 as the HCF? In that case, then 1050, both the numbers will be I think yeah, 1050, A and B have to be co-prime to each other. So then sum itself is 1050. This is not possible. So next one, if the HCF is going to be 525. So then if the numbers HCF is going to be 525. Okay, so 525 into a plus b is equal to 1050. So you will land up with a plus b is equal to 2. That means a and b, they have to be, the sum has to give you 2, they can be 1 and 1, there's no other way. Understood? Now, the HCF, maximum value of the HCF. So maximum value of the HCF becomes 525. It is possible, right? So the maximum value becomes 525. So now here I just give you a slight twist. Okay, So please figure out this. If x and y are distinct, in this case, a and b is equal to 1 comma 1. So what will happen is h into a is going to be nothing but 525 into 1, and this is also going to be 525 into 1. So both the numbers are going to be the same numbers. Okay, but now here if x and y are distinct, then what's going to be the maximum value of the HCF? 30 seconds for this. Okay, so now if x and y are distinct, then what do I do? I would target for the next HCF, correct? So if the HCF is going to be 350, 350 into a plus b has to be nothing but 1050. So you land up with a plus b is equal to 3. So a plus b is equal to 3 means the possible pair is only 1 comma 2. So one number would be 350 and the other number would be 350 into 2, which is going to be 700. Understood? And the sum definitely is going to be 1050. It satisfies all the conditions. So the maximum value of the HCF between x and y, in case x and y are distinct values, okay, distinct values here, then the HCF is going to be nothing but 350. That was it for it. Okay, great. Now please do this problem. Try this problem out. Fast money rush up to this because it's a very, very easy problem. Okay, so in a large school audience, the students are made to sit to watch the problems. If the teachers make a row of 16 students each, then 12 students are left out. So the number is going to be a multiple of 6 plus 12. If they make rows of 24 each, then 20 students will be left out. If they make rows of 25 students each, then 21 students are left out. And if they make rows of 30 students each, then 26 students are left out. All the positive remainders are different. So target the negative remainders. So 12 minus 16 is going to be minus 4. Again minus 4. Again a minus 4, minus 4. So the number would be in the format LCM, n into LCM of these numbers of 16, 24, 25 and 30. Okay, and after that minus 4. Okay, so please figure out, my dear, which is the least number in that format. First figure out what is the LCM of 16, 24, 25 and 30. First figure that out and put it on the chat box. I think 1200 is possible. Okay, this is nothing but 2 to the power 4. This is nothing but 2 cube into 3 power 1. This is 5 square. This is 5 power 1 into 3 power 1 into 2 power 1. So LCM of these numbers, the product of the prime factors 2, 3 and 5 are there. So 2 power 4, the highest power of 2 is going to be 4. The highest power of 3 that's available is 1. And the highest power of 5 that's available is going to be 2. So 25 into 2 power 4 is 16. And then into 3. So 25 into 16, how much does it give you? 25 into 16. 25 into 4 is going to be 100, right? So I think that's 400. 400 into 3 is going to be 1200. So minus 4. This is the least number that you will get. Okay, right. I think now one small thing I just want to go back here. I just want to go back here to, yes. Remember we had looked at here for a number which when multiplied by 3 leaves a remainder of 2. Maybe some substitution error had happened there. So a multiple of 3 plus 2, or the number could be in the format for figuring out the LCM and HCF of numbers. A number which was in the format a multiple of 3 plus 1, right? A multiple of 3 plus 1 and a multiple of 5 plus 2. Was it the same case? Have I written it down? No, yes, I think I have removed it now. Okay, so let us just check it out. Okay, when you divide a number by 3, the remainder was 1. When you divide a number by 3, the remainder was 1. So the number was in the format 3x plus 1. When you divide the same number by 5, the remainder was 2. So in that case, you had to equate these two and go on, because the positive remainder neither the negative remainder was the same. So you land up finally with 3x is equal to 5y plus 1. So x is equal to 5y plus 1 divided by 3. Now I can split it as 3y plus 2y plus 1 by 3. Now 3y is already divisible by 3. 2y plus 1 has to be divisible by 3. So by trial and error, we found out that y was equal to 1. So the minimum value of that number is nothing but 5 into y, 5 into 1 plus 2, which is nothing but 7. I think I had figured this out as 6. That was the error. I think I had cancelled to 1 then. So because of the equation, there was a problem. So here the least number is going to be 7. So how did I tell you to figure out the number? The LCM of x comma y. The LCM of the not x comma y, the numbers 3 and 5. Okay, and then plus the first number of its kind here. So n into that. So first number is going to be the first number that's going to be in that format is going to be 7. Okay, now you can start taking values of n to be from 0. So if n is equal to 0, then you will take the first number to be 7. If n is equal to 1, LCM of 3 comma 5 is nothing but 15. 15 plus your 7 is going to be 22. 22 also when you divide by 3, the remainder will be 1, and when you divide by 5, the remainder is going to be 2. So you can figure it out this way. Okay. So that time I think when I had equated, I think I had done it this way, and then I did a 5y plus 1 value. So we landed with 6. That was an error. Okay. So there are cases definitely when you will not have any number of that particular format, you'll have to double check it. But in this case, yeah, it was possible. Okay. Now, I think we are done with this. Okay. So I just want you to finish off this particular problem. Go ahead with this. Did we do it? No, right? Go ahead with this. One minute for it. So this was quite similar to a problem which I've already done, my dear. So I'll be starting the discussion, not too much of time. So how many pairs of integers exist as the product of x comma y, and HCF of x comma y is going to be 100. So as usual, let's take the HCF as h. So let the numbers be h into a and then h into b. Remember that a and b definitely have to be co-prime to each other. That is the condition that you have to put in your mind. Now product of these numbers is nothing but 1080. Correct. So I can say here, uh, how many pairs exist as the product of x and y. Okay, product of x and y and their HCF also. So product of x and y and the HCF. Now I have to take the HCF also. Now HCF is nothing but here h. Correct. So product of these numbers is 1080. So I'll end up with x cube into a into b is equal to 1080. Now let's try to prime factor this number. H cube into a into b is nothing but here, I can write this number as 2 cube into 3 cube, I think 2 cube into 3 cube into 5. Okay, so first thing, okay, I can take the value of h cube to be 1 cube. Okay, so the value of h should be 1. In that case, a into b would be nothing but 2 cube into 3 cube into 5. And a and b have to be co-prime numbers. A and b have to be co-prime numbers. Okay, and this number is nothing but 1080 only. So these a and b have to be co-prime numbers. And how many ways can I write 1080 as a product of two numbers which are going to be co-prime to each other? So first one I can write it as 2 cube, okay, into 3 cube into 5. This we might have already seen in the factors class, my dear, how to write it. Okay, so after that, here I can take it as 3 cube, okay, and then 2 cube into 5, and then 5 here, and then 2 cube into 3 cube. I can also have 1 into 2 cube into 3 cube into 5. So how many ways are here? There are 4 different ways. Okay, next possible way is I can take h cube is equal to 2 cube. Then in that case, a into b would be nothing but here 3 cube into 5. So a and b have to be co-prime to each other. In how many ways can I write it? 1 into 3 cube into 5 or 5 into 3 cube. I think these are the only two ways. Okay, and then the next case, h cube can be equal to 3 cube as well. So here a into b would be 2 cube into 5. So the number of ways in which a and b can be written as a product of two co-prime numbers, a into b, co-prime numbers, product of two co-prime numbers is 1 into 2 cube into 5 and the other is 5 into 2 cube. So again there are two ways. So the total number of pairs are going to be nothing but 4 plus 2 plus 2, that's going to be 8. And now if they ask for ordered pairs, then that will just be the double, that is going to be 16. Okay, ordered pairs means 1 comma 2 and 2 comma 1 will be treated as different. Okay, here they have just asked how many pairs, so I can just go with a total of 8 pairs. Ordered pairs would give me 16. Okay, now we'll just do a quick revision of this particular thing, which is going to be based on factorials, my dear. Okay, factorials is very easy. Okay, a slightly different kind of a problem which I had encountered, I have just put it here. Okay, so we'll just do only that one particular problem factors, but before that, yeah, let's go with a little bit of concepts. So first of all, what is a factorial of a number? The factorial of a number, just a minute, 1 minute here. So the factorial of a number, what is n factorial first of all? I can take here n factorial. Now I can take here n factorial as 1 into 2 into 3, that keeps on going up to n. Okay, so 0 factorial is always going to be 1, 1 factorial is always going to be 1, 2 factorial will be 2 into 1 and so on. Okay, and then 2 into 1, and 3 factorial would be nothing but 3 into 2 into 1 and so on. Now, the basic kind of question that will come is, what is the largest power of a prime number in a factorial? So, for example, okay, if they have given you here, let me just go with this here. First, a different example. How many zeros? How many zeros are there at the end of? How many zeros are there at the end of 15 factorial? So 15 factorial is 15 into 14 into 30, this keeps on going up to 1. Correct. So in this product, you have to get a 0 towards the end, means you should have multiplied the number with a 10. Only when you multiply a number with a 10, okay, you get a 0 towards the end. And a 10 can be formed by a combination of 5 and 2. A pair of a 5 and 2 will give you a 10. So to get a 10, you just don't need only 5s, only 2s, you need a pair of it. So remember that whichever is least occurring, obviously in a set of consecutive numbers, okay, 2 will be occurring every odd numbers, but 5 will be occurring only once in 5 numbers. So it depends upon the number of 5s. Let's check how many 5s are here. So 1 into 2 into 3 into 4 into 5 is there, yeah. Then after that, you have nothing but 5. Then in 10 you have a 5, correct? And then in 15 you have a 5. So there are 3 5s here. So if there are 3 5s there, okay, then I can say that these 5s will directly combine with the available 2s and give you zeros towards the end. So the number of 5s here was 3. Okay, now you could have simply done as nothing but everywhere wherever you get a multiple of 5. Okay, so in 15 check how many multiples of 5 were there? 3. This is the answer. But with the same question where how many zeros are there at the end of 25 factorial, what would you do? You choose the 5s now wherever there's a 5. 5 into 1, 5 into 2, then 5 into 3, 15, then in 20 and then in 25 also you have. Okay. So how many 5s? 1, 2, 3, 4, 5, 6. You don't get 5 5s but you get 6 5s. Why? Because that's an extra multiple of 25. In a multiple of 25 there will be 2 5s. Okay. So how to do these kinds of problems? Simply take 25 divided by 5. Okay, you get 5. Now you still can further divide by 5. So divided by 5 you get 1. Now this means that there are 5 multiples of 5 and 1 multiple of 25. So total number of 5s will become 5 plus 1, which is going to be a 6. Understood? So if at all, what is the largest power of a prime number? So if x is a prime number in a factorial, y factorial. So what I'll do is I'll just take that y and keep on dividing it by x. Okay, until and unless the quotient cannot be further divided by x. Then I will just add up all the numerators. I'll just add up the numerators. So if they're asking me what is the largest power of 5 in 100 factorial, I will take 100 and I'll divide it by 5. This gives me 20. Again 20 divided by 5 gives me 4. Now I can't further divide it by 5. So the answer is 20 plus 4, 24. So 24 5s are there. So 24 zeros will be there at the end of 100 factorial. That also you can see. Okay, both the inferences you can make. Right? Now, if the question is about what is the largest power of a composite number in a factorial. Composite number means like let's see 6, 2 into 3. So you have to check the number of 2s and number of 3s. A pair of a 2 and 3 will give you 6. But I know that 3 is a scarcer one. 3 is a scarcer one. So I'll check for the number of 3s there. Okay, a number of 3s how to check? We know, right? 3 is a prime number. Okay, like if it was for 12, then I would have checked the number of 2 squares and 3 power ones. Now since these two are very very close, now I will check for both. 2 squares also I'll check and number of 3s also I'll check. So whichever is coming lower, then I'll go with that particular value. Okay, so just a small problem here, my dear, for you all. Okay, please do take this problem. With this we'll wind the session. This was not of the usual type, slightly different problem that has been taken. So please try it out. We'll discuss it and then close the chapter. Okay. So yeah, see, given n is a positive integer less than 31. So how many values can n take if n plus 1 is a factor of n factorial? So they have clearly given us that n plus 1 is a factor of n factorial. So let us take values of n factorial. Okay, let's just consider the factorial still 10. So 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial, okay, 9 factorial, and let me take 10 factorial also here. So now they have said that n plus 1 is a factor of n. So here n plus 1 is 2. Is 2 a factor? No. N plus 1 is going to be 3. Is 3 a factor of 2 factor? 2 factor is 2. Is 3 a factor? No. Now the next value here is going to be 4. Okay, so n plus 1 is going to be 4. Is 4 a factor of 3 factorial? 3 factorial 6? No. Again here 4. The next one is 5. So is 5 a factor of 4 factorial? 24 5? No. Now the next one is 6. 5 into 4 into, see, 5 into 4 into 3 into 2 into 6, which is nothing but 120. Is 6 a factor of 120? Yes. Okay. And after that 6 factorial, next will be 7, right? N plus 1 is 7. Is 7 a factor of 720? No. And then here 8 is n plus 1. So is 8 a factorial of 7? 8 a factor of 7 factorial? Obviously yes, because in 7 you just have, this is 2 cube. So in 7, 2, how many 2's are there? 3 divided by 2 is going to be 1. So there are total of yeah. So there are this is 2 power 4. There are 4 2's inside. So this number definitely will be divisible by 2 cube. So there's now 9 here. So will 8 factorial be divisible by 9? See, there are in 3 also there's a 3, and in 6 also there's a 3. So this number definitely should be divisible by 9 as well. Now next one, 10. In 9 factorial, check how many like zeros are there. Then you can check whether it's divisible by 10 or not. 9 by 5, 1. Yes, there's 1 0 towards the end. The number is divisible by 10. Now n plus 1 is going to be 11. So is 11 dividing 10 factorial. All the numbers that come from 1 to 10 are coprime to 11. So it will not divide. So that's it. Okay. So if you look now, other than this particular value, okay, wherever n plus 1 is a prime number, wherever n plus 1 is a prime number, it did not work out. Wherever n plus 1 is a prime number, it did not work out, other than this particular case. So figure out all the values here, okay, for n plus 1 to be having a condition where n is definitely less than 31. So n plus 1 can go up to 31. N plus 1 will be less than equal to 31. Okay, so the prime numbers that are there are 2, 3, 5, 7, then you have 11, 13, 17, then we have 19, 23, 29, and 31. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 are there, and including this there are 12. Okay, but this answer 12 is for how many values can n take if n plus 1 is not a factor of n factorial. So what you have to do, from all these values you just have to subtract. From the 30 values of n, you have to subtract 12 values. So answer will be 18 for this. That's all. Okay, so hope this was clear to everyone. Okay, so please do practice on these 3 particular topics, 10 questions today itself. Okay, and please do not leave any single day without preparing. Each and every day is very, very important. Don't procrastinate things. Be sincere with your studies, and all the best for your paper. Do it.